Okay, so before we dive in here, I just wanted to, I don't know if we had talked about this yet, but I'd found the kind of the grading boundaries for your IB scores. So like basically 77 to 100% is a 7. 65 to 76% is a 6. Hi. Good morning. How are you?
Good, how are you?
Just dandy. He's not here. Thanks. And so on and so forth. So those of you that are like the diploma program people that are like trying to weasel out a diploma and then you're not sure about, like, you got some scary looking SL Chinese class where you're like, I can't pass this. This is an opportunity for you to like stock some points. This is a relatively easy course to get like 5, 6, 7 in, particularly if you've done well on the IA coming in. So just kind of keep that in mind. You know, you have my predicted IA scores for, you know, that I graded them at, so you kind of have an idea of where you fell. Most of us were kind of in like, you know, I think this range here in that 4, 5, 6 category, so you're already off to a good start. And realistically, if you can only do the stuff on your calculator, you're probably fine. Like 50% is a 4. Like total fail is a 4. That's a good IB score. Okay? Even if there's a bunch of stuff like I couldn't do a whole question, that's okay. Not a disaster. If you've done well on the things that you could do, you're probably going to be fine. So just wanted to do a little reassuring before. So let's, what do you guys want to start with, paper 1 or paper 2? Where are we further along in? Paper 1. Sounds good. Let's start on paper 1 then. We just got to start somewhere. Number 7. Mm-hmm. So we're looking at number 7 on paper 1 here to start. I put the wrong thing in. Good Lord, computer, you are being a pokey little bugger. All right. So I want to, it says the following graph shows the depth of water d meters in a river t hours after 12. At 15, so notice we're using military time here. So 15 is like 3 p.m. The depth of water reaches 7 meters, its highest level. At 2100, the depth of water drops to 1 meter, its lowest level. The depth can be modeled by the function d of t equals a times sine bt plus 4. And it asks us to find the values for a, b, and then the first time after 12 when the depth is equal to 3. So first thing I would do is say, okay, well, we have a formula booklet that we'd be given. I'm going to take a peek through this and see if what I can find. This sounds like a trigonometry topic potentially, so I'm just going to kind of scroll through to there. And we all took a course in trigonometry at one point. And nothing that we need in there. Cool. That's all right. All right, so what I am going to do, I'm going to remember from my trigonometry course, there's like key graphical features that correspond to the coefficients in my trigonometric formula. So if we have the general form of a trig function kind of looks like this, right? We have like three key features: the midline, the amplitude, and the period that correspond to the coefficients. The period is the length on the x-axis for one cycle. So the graph goes up, goes down, and returns back to its starting height.
So is that like where it crosses the line?
Where it crosses the line. So this is the period, that distance. It's okay with that? Okay. So the amplitude, so we started at 4, we went up to 7. How much did we travel there? 3. So our A is always, or the absolute value of A is going to equal the amplitude. So in this case, then A is going to be plus or minus 3. Everybody's okay with that? Now, to decide whether I want positive or negative, I'm going to look at which trig function I have. In this case, it's sine. And I know sine goes from a midline point to a maximum to midline point to minimum to midline point, like y equals sine x. Because we have a max following here, I know that this is positive 3. Everybody's okay with that? If you're not sure, when you're done, just graph what your answer is on the calculator and see if it matches the picture that you have, right? And then I'll try to be clever here in a minute and try to show you how to do this, maybe entirely on your calculator. Yeah, that's pretty rad, right? The midline is just going to equal the k. So the midline here is going through 4. That's the k. That matches what we saw or was given to us in the problem, right? And then the period is 2 pi over the absolute value of C. So hard to tell what the full period is from the picture, right? Because the graph's full period ends outside of the picture. But this would be half, right? So my full period should be 12. So if I solve that for C, I get pi over 6. And I can always, it should really be plus or minus, but I can always just choose it to be positive to make it work and adjust otherwise. I divided both sides by 2 pi and then flipped both sides to get the C out of the denominator. Because I saw that half of a period was 6, where we've gone from 0 to 6. So I just multiplied it by 2 then. Again, since the graph, the end of the graph was off of the scale, so 1 over C then would be 6 over pi, and that's the B in our problem. But let's try to do this cleverly on our calculator. So what I'm going to do is I'm going to try to do this with just a regression equation. So I'm going to collect, bless you, I'm going to collect 5 points. I'm going to collect those 5 points that I've circled there in green, and I'm going to enter those into my calculator. So I have like 0, 4, and then 3, 7, and then 6, 4, and then 9, 1, and then 12, 4 again. So I did that. Everybody's okay with what I did there? Just picking the midline points and then the extrema. And I'm just going to do stat, calc, and I'm going to scroll down and choose sine reg. I think I have one iteration. I know the period was 12. And let's hit calculate and see what it gives me here. So there's an answer. Notice that 6 divided by pi. Oh, do I have it flipped? I might have it flipped. Yeah, I think I should have had pi divided by 6 there for my B. Yep. But that is massively easy, right? So I had one iteration because I just have one cycle of the graph that my points are covering. The period was 12. I knew that from before. And I just entered in the formula, or entered in the points and hit give me a regression equation for it, and it spat out something that'll work. Yep. So I pressed stat and went over to calc. This is where all the regressions live. and I scroll down to the sign reg, and I did all of these things. Again, one iteration. I put my x's into L1 and my y's into L2. My period was 12, and let's go ahead and store that into Y1, because that'll allow us to do part C pretty easily. So it says find the first time after 12 when the depth is equal to 3. So I'm just going to put 3 in. What does the error say? What's it say? Oops. I just have to graph it in, I guess, in radians here to get. That means that when you typed your points in, you have more x's than y's, or you don't even have any points that you typed in. So go back to the stat edit and make sure that your points are correct. So again, if noon is time 0, right? We're looking for this intersection here. So second, intersect, enter, enter, and then for my guess, since there's lots of intersections, I got to move it close. So time 6.64 or 65. So to get that properly formatted, though, because it says give your answer to the nearest minute, so the time should be 12 plus 6. That'll be my hours. And then my minutes will be 60 times 0.65. So when I do that, I get like 1839 as my time. Yeah, so like if I went to if we look at the mark scheme for this, where's the number 7? Oh, just got copied out of order. So for part A, there's just one mark, whether you got the coefficient for A. For part B, there were 2 marks. You would have gotten 1 mark for identifying that the period is 12. And then you get your second additional mark for the value for B. Now they have pi over 6 here. I would suspect they would take that rounded to 3 decimal places. And then for the third one, there are 3 marks available. 1 for writing the equation that you're solving. Another for the answer, the value for t, and then the third for translating that into hours and minutes. So like most of these questions have partial credit available, particularly if they're, well, specifically when it's like, it tells you the number, see these things in brackets over here, that's how many marks the question is worth. So if it's a 1 mark question, really no, it's just like, did you get it or not? But anything with more than 1 mark to it is going to have, you know, like points associated with like, did you get to here? Did you get to here? Did you get to here? So like, write the equation that you're trying to solve. That's usually a mark. Like, can you get, you know, through part of the way? That's another mark. Can you get to the final answer? That's a mark. Can you, you know, format your answer properly? That might be a mark. You know what I mean? Yeah. So the mark scheme will show you like what they're, you know, what they're looking for. If you want to go back and look at that as you're kind of reviewing things, that's why I included that along with my worked out. Geraldine, does that feel okay?
Could you
Yeah, so on the calculator, I just stored the regression equation that it calculated for me. And then I typed in 3 for y2. And really, I should probably adjust my window to match what we're seeing here, because at 3, it's going to hit somewhere over here, right? You can see clearly in the picture. So if I set this to match their windows, so 0 to 9 on x's, and then 0 to 8 on the y's, and then hit graph. So this should look just like the picture I'm seeing. So now I'm just looking for this intersection. So second trace, intersect command, enter, enter, enter. So 6.65 is the value for t. But I have to translate that value for t into an actual time, into hours and minutes. So 0 here is corresponding to noon, right? Because t is hours after noon. So to turn that into an hour, I'm going to do 12 plus 6. And then to do the minutes, it's going to be 0.65 of an hour. So 60 minutes times 0.65 gives me 39. So I'd say the time would be 1839 or 6:39 p.m. Is that? Okay. So on a trig one like this, I would just use the sine reg on my calculator. I would just enter the points, figure out the period, and then sine reg it. And as far as this goes on the test, with you showing your work on a question like this that has parts A, B, and C, I'm not labeling what I'm working on. I'm just going to leave it as all one thing, and I'm not circling any answers. I want the reader to have to read through the whole thing, because if I did something right along the way, I want them to find that and give me the mark for it, even if I end up with what I would think is the wrong answer and I go too far, I do something I shouldn't have. I don't want to declare what my answer is, because if I get the right answer along the way, I should get full marks for it, even if I go further and screw it up afterwards. So I don't want to circle anything and declare this is my final answer. I want them to have to read through my work and look at what's there and decide. So like in my space over here, the work that I would show is I would do like, I'd be like, okay, I'm going to do 0, 4, like 3, 7, 6, 4, 9, 1, 12, 4. So I would say then, okay, then I did sine reg, 1 iteration, period is 12. And then I would say that like, A is 3 and B is like 0.52, I forget what it was. And then I would say, okay, well, like 3 is equal to 3 sine of 0.523t plus 4. And I'd say then like t is equal to 0.665. And then I'd say like, I'd write this like I did before.
I was doing a lot of level.
What mode is your calculator in? Okay, so when we did this, when the calculator does this sine reg, it's going to do it in radians. So that's a great question to ask. So if you're, like we do need to state that because this is in So if you change your calculator mode to radian, you'll get a more sensible picture. We're putting 3 into y2 and then graphing and finding the intersection. And again, even if you run into something like this where it's like, you know, you end up, of the 6 marks, you're only getting 1 or 2. Not a disaster if you're like getting all the marks on another question. That averages out to still put you in really good shape with just those 2 questions, not to mention the rest of the test, which ideally goes fairly well. What else did you guys want to talk about from paper 1? Was there any other problems that stood out? Number 11. Okay. All right. The following diagram shows a semicircle with center O and diameter PQ. A rectangle OABC is also shown, such that AB is 8 and OA is 5. We're asked to find the length of arc BQ. So to find the length of that arc BQ, I'm going to know that the measure of that length, or the measure of that arc BQ is going to be the angle BOQ over 360 times 1/2 of 2 pi r. Is everybody okay there? Okay. So I'm going to start by finding r. I know r is the same as BO, right? That's a radius for that circle. So I can just find that using the Pythagorean theorem. So BO is going to be the square root of 89. So far, so good. Now, I'm going to find the angle BOQ next. That's the other piece that I need to fill in, right? Because I don't have this piece or this piece. Hi.
Hello.
He's here now. Paulie, looks like you're getting here just in time to go home early. So what I'm going to do is I notice that BOQ is going to equal 180 minus angle BOP. You good with that, Joey? Because it's just like, that's 180 degrees, right?
What is the whole thing?
Like half of a circle, like this is a 180-degree angle, right? So I'm just gonna, this piece then is 180 minus the other piece, right? That's all I'm saying there. So to do that, I have to find then angle BOP. So to do that, I notice that, hey, this is 8 and this is 5. So I can do like tan inverse.
We should probably change our calculator back to degrees.
Absolutely, yes. So tan inverse of opposite over adjacent, so 5/8. And when I type that in, I'm going to get like, yeah. Like 01 or something, right? Okay. So then this is going to be 180 minus 3201. So that's going to be 147.99. Then I go back up here and I can fill in then the 147.99 times 12 times, or I'm sorry, 1/2 times 2 times, well, those just cancel out, pi root 89. Because it's a semicircle. Oh, no, it shouldn't be there at all. You're right, Geraldine. Great googly moogly. Thanks.
Why'd you get rid of one?
It wasn't supposed to be there. It was a mistake. I made a mistake. That I could have done it two ways. I could have done 360 with 2 pi, or I could do 180 with 1/2 of 2 pi. But I can't like do one of one and one of the other. So. And that formula that I used there, that's gotta be in here, I would think. Functions, geometry, and trigonometry. Yeah, length of an arc. L is equal to r theta, where r is the radius and theta is the measure, or the angle measured in radians. It's a terrible representation of this formula, but that's that's the formula I used. So it's degrees divided by 360. So BO is the diagonal of that rectangle, but it's also, there's a right triangle right here.
Yeah.
Does that make sense? So just about like seeing what you need. So it says this one was 5 marks. Let's look at where the marks came from. So 1 mark for finding the radius, square root 89. 1 mark for finding the Yeah, one point for finding the angle there, or the 32-degree angle. Another mark for finding the 47.99. And then your final mark for using the arc length formula and then getting the correct answer. And their workings are just like, I hate this formula that they're trying to use to do this. Like, it's such a convoluted, like unnecessarily difficult formula. Where was I at? Here was I. Should we go on to the next paper, or do you guys have more questions here? Okay, let's go to paper 2 then. We can always circle back and do more paper 1 stuff next class if you guys, as you're looking over things again, want to go back and circle back to things. Where do you want to start on paper 2? Mm-hmm. All right, so this says, notice on paper 2, the questions are more lengthy. There are fewer questions, but now you're going to like mix multiple different concepts from that we've studied, rather than being kind of like all one topic. Now you're going to run into like, oh, here's going to be like mixing. It'll be fine. Says, Zavvi conducted a study to see if there's a relationship between the price of an apartment, Y, and its distance, X, from the city center of Melbourne. They took a random sample of 6 typical apartments along a train line. Zavvi obtained the data shown in the following table. A plot of the data seen in the graph. Write down the value of the Spearman rank correlation coefficient, RS. So the first thing I want to do a Spearman problem is I need to rank these values. It's really convenient the way they've ordered them, because where's the smallest values? Yeah, so like smallest, next smallest, biggest, and so on. And then here is the biggest, and then it proceeds down from there, right? Yes. Really degree, unless you're doing the sine regression. Only do, so they don't really, I don't think that they would intend for you to do that trig problem on paper 1 using the sine regression. But you can, and that would be my advice, because it's really simple. You don't have to remember any of the little formulas or like any of that nonsense on like how to get. But to do it and graph it, the calculator needs to be in radian mode.
Yeah.
Anything else you do on this test should be in degrees. So that's the only time I would switch to radian mode. And as soon as I'm done with that problem, I'm switching back. Cool? All right, so Geraldine, and it doesn't matter whether I went, counted the biggest one as number 1 and the smallest one as number 6. It doesn't matter. But now I'm just going to enter 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1 into L1 and L2, and then do the lin reg, and that'll give me my RS. Does that feel good? You don't need me to go through doing that. Show on the calculator. Okay. Then it says find the Pearson product moment correlation coefficient R. So to do that, I'm just typing in the data from the table. I'd probably do that into L3 and L4 so that if I needed to come back and use that other data, I still have it. And then do a lin reg on that. And it'll spit out the R. So I want to take a moment here and remind us how to do something, because it just kind of came to my mind. So if you have your calculator with you, I invite you to take that out to follow along. So at the start of this, before you start this IBSL exam, they're going to make you reset your calculator memory. When you do that, you're going to lose 2 things that you want. 1, your calculator is going to move from degree mode back to radian mode. So you have to make sure you switch that back right at the start. The second is the R values are going to stop showing up. So you have to turn that option back on. Okay? To do that, the easiest way to do that is to open the catalog. So you'll press second and the number 0. And then the command you're looking for is called diagnostic on. So if you press the X to the -1 button where it has the little D above it, it'll skip you all the way down to the D's. And then you can just scroll till you see diagnostic on. Select enter. Oh, I put it in the wrong spot. You'd select the diagnostic on, press enter, and press enter again to where it says done. And after you've done that, you're all set. But right at the start of the test, as soon as they make you clear your calculator memory, you need to do those 2 things. Put your calculator back into degree mode and turn that diagnostic back on. Does that feel okay? So just as a reminder, it's easy to do both of those things, but you got to remember to do it. Okay? Because you need those diagnostics coming up and getting those R values, because that's not something you want to do by hand. Not enough time. It's too lengthy of a calculation to do that by hand. I want the calculator to do it for me. Okay. And then how do we tell if the correlation is positive or negative, strong, weak, or none? You look at the R value. What am I looking for the R value to tell if it's positive or negative? Just if it's positive or negative, right? Yeah, it's that easy. What's strong going to look like? Close to 1 or -1. What's weak going to be? Closer to 0, and no is going to be basically 0, right? Or darn close. Right? Usually 0.7 and then to 1 is strong. Like 0.3 to 0.7 is weak. Less than 0.7 or 0.3 would be kind of none. When you did the lin reg, it would have spit out for you the values for A and B, right? No problem there. According to this model, state in the context what B represents. So B is the y-intercept, right? So in this problem, your x's are representing the distance from city center of Melbourne, and Y is representing the price of an apartment. So your B, let's say B was 5. I don't know what it is. I would say that B equals 5 means that at a distance of 0 kilometers from the city center of Melbourne, the price of an apartment would be B millions of dollars. Right? So I'm using all the verbiage. I'm just translating what's the, like using the verbiage from the problem to just describe what B is in the context of the problem. So the X is 0, the Y is B. I'm just using whatever X and Y represent, the units from the problem, to just state that. And that's a problem we had done in class, right? You guys remember doing that? Part D says, Zavi uses the regression equation to estimate the price of a typical apartment located 19.6 kilometers from the city center. So you're just plugging that 19.6 in for X. Whether you do that by storing the regression equation, doing like Y1 of 19.6, or you just like use your rounded values, it's fine. I would write down on my paper kind of what I did, like show it plugged into your answer. And then state 2 reasons that Zavi might use to justify the validity of this estimate. Yes. So whenever you're using a regression equation, there's 2 things that you'd want to have in order for that prediction to be valid. So the first one is you want the model to be a good fit. Your R or R squared value will give you that information, right? So I would say because the R value is close to 1, or that, I guess in this case, -1, I can tell because it's sloping down, the model is a good fit to the data. Everybody's okay with that? The second thing you want to have is the value that you're plugging in. So this 19.6, I want to fall within the X values I use to make my model. So notice that 19.6 is greater than 7.0 and less than 20.9. So what I'm doing is, what's the word called for this? Interpolation. So if you use that word, you should be golden. But if you just say, if you can't remember the word, you just can say that because 19.6 is greater than 7 and less than 20.9, that should be good enough, even if you don't remember the vocabulary word. Does that feel okay? Or even if you said because 19.6 falls within the X values used to create our model, I would think that would be sufficient. Don't get hung up on the vocabulary. Geraldine, you feel good on that? Okay. Who's next? What else do we want to talk about? Three. Okay. So a shop uses the following model to estimate N, the number of smoothies sold per day, in terms of X, the price of a single smoothie in pesos. The maximum number of smoothies the shop can make a day is 400. Find the maximum price they could charge per smoothie for the shop to sell 400 smoothies in one day. So N in my model up here is for the number of smoothies and X is the price, right? So I'm just going to plug 400 in for N and then solve for X. You could do that algebraically, or you could type it into your calculator and just graph and find the intersection. That's okay. The 2 marks, I assume 1 mark is going to be for writing 400 equals 40,000 over X squared. And the second mark will be for your answer. Let me check real quick, but I'd be shocked if that wasn't the case. Yeah, so 1 mark for writing the equation and the second mark for the solution. Joy, does that feel good?
Yeah.
Okay. Part B says, on a day when the shop sells smoothies at 50 pesos each, use the model to find the number of smoothies sold. So 50 pesos is a price. That's going to go in for the x squared, and out it's going to pop our value for n, the number of peso or the number of smoothies sold. So I'm just plugging 50 in for x and seeing what the number is that pops out. I think it says 16 is what I get. And then it says part 2, the total income from the smoothies sold. So we sold 16 smoothies for 50 pesos a piece. So I just do 16 times 50, and that should be my total amount of money that I brought in. Does that feel good? Okay. So again, like nothing complicated yet, right? This is all pretty easy stuff. It's just like, can I read this and understand? The cost of making each smoothie is 20 pesos. The profit per day, P, is the total income from the price or from the sale of the smoothies that day minus the cost of making them. Show that according to the model, P is equal to, I don't know what happened here, but that's supposed to be an equal sign. 40,000 over X minus, that's supposed to be a minus sign, 800,000 over X squared. So to do this, I started by saying like, profit equals number of smoothies sold times the price per smoothie minus the number of smoothies, I guess really just times the cost per smoothie. So the number of smoothies sold in this case is N. The price per smoothie is X. The number of smoothies sold is N. And the cost per smoothie, we're told, is 20 in the problem, right? Now, when I look at this model, there's no N's in it. So I need to get rid of those N's. So if I go back and look, I know that N is equal to 40,000 over X squared. So I'm just going to drop that in. And then when I simplify down, boom, boom, and I multiply across, I got exactly the thing that they stated, right? So again, it told me how to calculate profit in the problem, right? It's just the number of smoothies times the price minus the number of smoothies times the cost. So I wrote that down, and then I just started plugging in values, or expressions that were given to me in the problem, and did like a little bit of algebra, and bingo, bango, bongo, I'm done. Now, even if you had trouble on that, to do part 2, you can use the answer in part 1, right? It gives you the answer in part 1 because you can't do anything if you don't have that equation correct. So it's giving you the equation correct in part A. Use it. Even if you can't do part 1, use the answer from part 1 that's given to you to do parts 2, 3, 4. That's why the problem is set up this way, so that parts 2, 3, and 4 are still accessible even if you couldn't do part 1. Does that make sense? So find dp dx. What does dp dx mean? The derivative. So I just take the derivative of the function, right? So to do that, I would have thought about this as 40,000 times x to the negative 1 minus 800,000 times x to the negative 2. So when I take the derivative, I get that, right? Multiply by negative 1 and then subtract 1 from the exponent. Multiply by negative 2 and then subtract 1 from the exponent. Part B says find the value of x for which dp dx is equal to 0. So into my calculator, I am typing this. And the domain that I'm going to use, I'm going to go x from 0 to what? So when I'm typing this into my calculator, the window I'm going to select is going to go from 0 as my x min to what value of x is my max? 10. Why 10? Because way back in part A, that was the maximum price that we can charge. Oh, no, not that. No, I don't think you, no, it's not 400. I don't know what you'd pick, but like 100 should be fine. Oh, yeah. $100 should be fine. I don't know. Like the X is a cost or the price that you're charging for a smoothie. So whatever. You do that and you just find where it crosses the x-axis. You just do this graphically, right? And then part 4, find the number of smoothies sold when the profit is maximized. So then you just take your answer for part 3 and plug it into the x in the original equation at the top to get the number of smoothies, right? N equals 40,000 over x squared. So you're just plugging your answer into that thing and you're done. So again, like from the math side, these are all really easy things to do, right? Nothing complicated about what it's asking. The hard part is reading the question and knowing what to do. Like, how do I do this? And if it's like, this is starting to get complicated, you're probably doing too much. There's probably an easy way to do this. Notice none of these things on here required like lines and lines and lines of calculations. The most complicated problem was probably that arc length one because it was a single question and didn't have any parts to it. It was 5 marks. I was expecting to have to do a fair bit on that. One of these guys that's like, well, I guess part C is 9 marks, but that's split over 4 things. So again, I'm not expecting any of these 4 things to be lines and lines of calculation. I'm expecting like this should be something fairly easy that I can just knock out on my calculator. The derivative. You can do that, or you can just graph the derivative and then use the 0 command instead of the intersect. But either is fine. Okay. So I'm going to have negative 40,000 x to the negative 2 plus 1,600,000 x to the negative 3. And then I don't need that. We can probably just go from 0 to 100 would be fine. And here, it doesn't really matter the y min and y max, but I need to see the x-axis. I need to see the graph cross. So I'm going to do negative 10 to 10. And there we go. There's my spot there, Joey. Yeah, come show me what you got on there. I'll take a look.
Maybe I gotta put like another 0 on that.
Yeah, I think you should have 5.
Okay.
There you go.
Sweet.
Yep. You want to call this a day for today? So next time, take a look through things again. Again, highlight the stuff that you're like, ooh, I don't remember how to do this on my calculator. Ooh, this was tricky. Particularly, I would look at the like that normal distribution problem. That test did not go great for many of us. Would be the number one place I would highlight, making sure that you've like looked through things and feel like you're confident that you can use like normal CDF, PDF, inverse norm, binomial PDF, CDF, can do those sorts of things confidently. So we'll make sure we'll talk about that one next time.